We are looking at the review for Unit 1 test. I had to redraw what was on here, so this is the picture that's in your Unit 1 review, but I had to redraw it because it didn't translate over to this very good. So we're going to look at all the problems here, starting with number 1. Name a line that contains point J. Well, looking for point J, we see point J right here, so we know what line we're talking about. We're talking about this line right here. Is it line DB? Well, D and B are on that line, so first glance that looks like the correct answer. Let's go through to see if any of these other ones work. GF, and actually I wrote that down wrong, didn't I? That should be GF right there. That should be an F. I'm trying to erase. Not that. Let's just scratch that out and put an F right there. That should read GF. That is not this line right here containing point J. So that's not it. Line N, this is line N, that is not it. And then line P, which again is right here, so no, that is not it as well. So my answer to number 1 is A. Okay, moving to number 2. Name the plane containing M and P. If you remember, we name a plane by a capital letter, or we also name it by 3 letters in the plane. We do not label it by the name of a line. We do not label it by 1 point. So GFC, if GFC is included here, which we have G, we have F, and we have C, those are 3 non-collinear points which should work. Let's check JDB. I'm looking for a J. Here's J, D, B. Those 3 points are in this plane, but it is not the answer because they are collinear. If you remember, they have to be non-collinear, which GFC is. So that is my answer. Looking at 3, what is another name for line N? Line N, we have right here, line N. Another name for that would include any of these 3 letters in a combination. So A, D, or C it has to have, and it has 2 letters. So not JB, DC, we said A, D, or C. This looks like it's correct. Let's keep looking. GF, no, those points are not on that line. AC, but we just have AC. We don't know if that's a segment or array or what it is, so we're not including that. B is correct because it has the correct symbol above it. Okay, we're looking at number 4 now. It says, name a line that contains point A. Point A is, let me do something really quick. Point A is right here, so again, it's the same one. We could call that line N, or any of those points, A, D, or C, need to be included in that. So we could call it line N. Line N is not an option anywhere. It is definitely not line M. And it is not K. K would be another name for this plane, but that's not it. So again, it's going to be including D and C. Notice the notation. DB doesn't work. The answer there is A. Name a point not contained in A, D, or F, G. First of all, looking at this, is K a point even? K is not a point, so we can cross that out. Let me change my... we can cross K out. Let's see if A is on AD or FG. A, so FD, or I'm sorry, AD, there is AD, and there is FG. So on number 5 we have A is included, so that's not the answer. H sits out here all by itself, so it is not included. D is included, so my answer would be H. H is not included, so my answer is C. Okay. Next, 6. Which of these is not a way to refer to line BD? BD is this line right here, and a way not to refer, we could refer to that as line M, or anything with the letters J, D, or B, of course with the correct line above those. So M, J, D, or B. So this is a correct way, B, but we're not going to use that. And we said M or J, D, B. Well, there's JB on A, and it has the correct notation. Look at this. Do we use 3 letters? We didn't even need the picture to know that that would be one that it could absolutely not be. So my answer there would be C. So I have A, B, B, A, C, C as my answers here. Alright. Okay, we can see these fairly well, and we're going to name 3 collinear points, 3 points on the same line. We are looking at BLD. That would be here, BLD. That should be a B right there. Those are not collinear, are they? They're coplanar on the same plane, but not collinear. What about CLB? CLB, again, coplanar, not collinear. KAC, KAC, coplanar, not collinear. And the last one is DFG, DFG. We can draw a line through those 3 points. Those are collinear. Okay, number 8. How many planes contain these points? Now remember, planes are how many faces. We've got this is a prism, the name of this shape, and we've got that face, and we've got that face. We also have this face right here, and we've got the back face, and then we've got the bottom. So if we count each of those faces, we have 3 around the sides, 2 on the ends. That leaves us with, okay, great. No, this is not asking for faces. This one asks us how many planes contain, so ignore all of that. That will come up later. How many planes contain points BCA? Well, there's B, C is here, and A is here. How many planes contain those 3 points? Well, those are all coplanar. They are all included on one plane. So that's my answer. Number 9, it says in this figure, angle AED is 131. So this is 131 degrees. Which of the following statements is false? BEC is 131. Well, these two are intersecting lines creating vertical angles. That makes BEC 131. So is that false? No, that's absolutely true. Next up it says DEA and AEB are adjacent angles. Those are adjacent. They share a common side. So that's incorrect because it's a true statement. AEB is 49. There's AEB, 49. Well, if 100 DEC and DEA, 131 plus 49, they should add up to 180 degrees, which they do, because this is a straight angle which measures 180 degrees. So that's true, so that's incorrect. This has to be my answer, but let's just double check it. We have DEC, which is right here, DEC, and DEA are vertical angles. Well, DEA is actually adjacent. They share a side, so they cannot possibly be vertical angles. That makes that statement false. What is the negation of this statement? If Miguel's team won the game, the negation would be Miguel's team did not win the game. That's C. That's the negation. You take the original statement and just put a not in there, and we get the negation. What's the inverse of this statement? So we have our conditional statement right here. This is the hypothesis. This is the conclusion. So in an inverse statement, we take the hypothesis, we insert not, in both the hypothesis and the conclusion, and we keep it in the same order. So my answer here is C. If she does not study hard in math, she will not succeed. Notice it's the same order, we just replaced it with not. What is the converse? This is the hypothesis, this is the conclusion. When we do this, we just flip-flop them. They switch places. And when we read those choices, we see that C is the answer. The converse takes the hypothesis and flips it with the conclusion. So you actually start with the conclusion. And the contrapositive is when we take the hypothesis and the conclusion, we flip them, and we add the negation to each one. So what we end up with, if a figure is not a quadrilateral, then it does not have four sides. C is the correct answer. Okay, we don't change any other words other than putting the word not in there, and then we flip the hypothesis and the conclusion. Okay, 14. Determine whether the conjecture is true or false. Give a counterexample. Okay, given two angles are supplementary. Conjecture, they are both acute. Is this a true statement? Remember, supplementary is where two angles add up to equal 180. Now remember, acute angles are all less than 90 degrees. So, this actually is a false statement. You cannot possibly have two angles less than 90 adding up to equal 90. So it is false, so B is not true, but now we have to read. Either both are right or they are adjacent. Is that correct? Does adjacent have anything to do with supplementary angles? No, it does not, so that's not correct. False, either both are right or one is obtuse. That's actually a true statement. If they're both right angles, they could both add up to 180. Or one would have to be obtuse and the other one would be acute. So that would be correct. Now look at D. False, they must be vertical angles. Yeah, there's nothing. Vertical angles has nothing to do with supplementary. So my answer is C. Okay, looking at number 15, let's go ahead and solve this. You'll notice it says M is the midpoint of RS. So let's just draw a picture of it. RS. M is the midpoint. The coordinates of S are 6, 2. The coordinates of R, actually they give us the coordinates of M, which is 5, 6. Okay, so what we've got is the midpoint formula. If you remember that, you take x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Those will give you your coordinates. Now in this case, we already have our midpoint. we don't have our x or our y of our endpoint. So what we're going to do is we're going to add our x's, 6 plus x divided by 2, and that's going to equal our midpoint x, which we know to be 5. We're going to do the same thing with the y's. Y plus 2 divided by 2 is going to be equal to 6. So now we solve this, multiply both sides by the denominator to get rid of the fraction. We get 6x, slide up. We get 6 plus x equals 10. Subtract 6 from both sides, and x equals 4. So that's the coordinate of my endpoint. And on the y side, multiply by 2, and we get y plus 2, because the fraction cancels, equals 12. Subtract 2, and y equals 10. So 410 is my endpoint, which is A. Okay? All right, let's... Okay, BD bisects ABC, so let's draw a picture to help us get a better visualization of what this looks like. We have ABC, and BD bisects ABC. So this says that ABC is 7x, so the entire angle is 7x. Now ABD, we're talking about this angle right here, is equal to 3x plus 5. We're supposed to find DBC. Basically, we're supposed to find this angle right here. Well, if BD bisects this angle, then these two angles are congruent. That means DBC is also 3x plus 5. How do we find the value of 3x plus 5? Well, we have to solve for x first, and in order to do that, we need to find that value. So we're going to write an equation that lets us solve for x. 3x plus 5 plus 3x plus 5 is going to equal the entire angle, which we found to be 7x. So we can use this equation to solve for x. 6x plus 10 equals 7x. Subtract 6x, and we find that x is equal to 10. Well, if you remember, it says find the measure of DBC. This is DBC. So what we're going to do is take this 10 and plug it in for my x. So we're going to take 3 times x, which is 10, plus 5. 30 plus 5 is 35. C is my answer. Okay, number 17. Find the distance between points P and Q to the nearest tenth. We're going to use the distance formula, and we give it, you have it right there. So we'll call this x1, y1, and x2, y2. So actually, let's do this. Zoom in a little so we can have more room. We're going to take 8, subtract 7, because I'm subtracting my x's squared, plus my y's, 2 minus 4 squared. 8 minus 7 is 1. We're going to square that. 2 minus 4 is negative 2. We're going to square that. When we do, we end up with 1 plus 4, or the square root of 5. We can't simplify that, but we're going to, it says to find it to the nearest tenth, so we're going to plug that into our calculator and let it find what the square root of 5 is as a decimal. When we do, we get 2.2. Okay? Okay, let's look at number 18 now. Find the value of Ln if m is between L and n. So we have L and n, and m is between it. Doesn't say it's the midpoint, it's just between it. Lm is 6a, mn is 9a, but notice that it says that Lm is also 6. So these two values are equal to each other. 6a equals 6. Well, if I solve, a is equal to 1, isn't it? Now it says find the value of Ln. Ln is the entire distance. Well, if Lm is 6, let's rewrite it right here. Lm is 6, and Mn is 9 times a. We found out a was 1, so 9 times 1 is 9. Add those two together and we can find Ln to be 15. Well, and then we have 9 and we have 6. So those are your answers on number 18. Number 19, two angles are supplementary. That means they add up to 180. So let's just call this angle 1 and angle 2. One angle is 26 more than the other. So we'll say that angle 1 is going to be x. Angle 2 is 26 more than x. Find the measure of the two angles. Well, when I add them together, they add up to equal 180. So I can take x, which is angle 1, add it to angle 2, which is x plus 26, and set it equal to 180 degrees. 2x plus 26, combine like terms. Subtract 26 from both sides, and we get 154. Divide by 2, and x equals 77. And what was x? Angle 1. So what's angle 2? Well, I need to plug it in here, so 77 plus 26 is 103. Alright, looking at the next one, the measure of two complementary angles are 6y plus 3. They're complementary, that means they add up to equal 90. So if this is one and this is the other, then 6y plus 3 plus the other angle, which is 4y minus 13, when I add them together, we get 90. Combine like terms and solve for y. 10y, 3 minus 13 is going to equal negative 10, equals 90. Add 10 to both sides. 10y equals 100. Divide by 10, and y equals 10. So what does that y mean? Is that my answer? No, they want angle 1 and they want angle 2, so let's plug that in. Angle 1 is 6y, which we found to be 10, plus 3. It's going to be 60 plus 3 is 63. And angle 2 is 4y, which is 4 times 10, minus 13. 40 minus 13 equals 27. And when you add these two up, they do equal 90 degrees. Okay, and looking at 21 here, we have angle A and angle B are supplementary. That means they add up to 180 degrees. The measure of angle A is 3m. The measure of angle B, this should read, and I think we corrected this in class, but the measure of angle B should be equal to m. Okay, so let me zoom in here. If this is the case, then that means that angle A, 3m, plus angle B, which is m, is going to equal 180 degrees. When we combine like terms, this is what we end up with. Solve it, divide by 4, and we find that m equals 45. Well, the question asks for the measure of angle A and the measure of angle B. The measure of angle A is 3m, so 3 times 45, which we get 135. And the measure of angle B is equal to m. Well, we found that m was 45, so the measure of angle B is 45 degrees. Okay? Alright, next up we have number 22, and we're asked to find both angles supplementary to COD. COD is right here. So we're looking for two angles that basically will form a linear pair, which makes this supplementary. If you'll notice, this would make a linear pair, so our angle here is going to be DOE. That would be my angle that would make this supplementary to COD. And my other angle would be AOC. That would also be supplementary to that red angle. Remember, they make a linear pair. AOC. Okay, number 23. Identify the hypothesis and conclusion of this conditional statement. If tomorrow is Monday, then yesterday was Saturday. Remember, tomorrow is Monday. What follows if is your hypothesis. Tomorrow is Monday. Your conclusion is whatever follows then, which is yesterday was Saturday. Okay, next up, we're going to write this conditional statement in if-then format. All triangles have 3 sides. So we're going to first find the hypothesis. So we're going to go ahead and say that all triangles. So we're going to say if a figure is a triangle, then it has 3 sides. Okay, and 25, last one on this page, we're looking at two conditional statements. We're going to write two conditional statements that make up this biconditional statement. So we have, I drink juice if and only if it is breakfast time. So you remember what's in blue here is going to be the hypothesis of my statement, which always starts with if. If I drink juice, followed by my conclusion, then it is breakfast time. And the converse of that is where I write my conclusion first, starting with an if statement. If it is breakfast time, and then I put my hypothesis. Then I drink juice. Alright, let's look at the next page. Okay, last page here, we're looking at the law of detachment on number 26. Use the law of detachment to draw a conclusion of the two given statements. We have a conditional statement. It starts with the hypothesis. If two angles are complementary, then the sum of their measure is 90 degrees. Notice that our given statement is our hypothesis Therefore, we can conclude that my conclusion is going to be based on the conditional statement, the first statement. So L and M are complementary, and remember it says if two angles are complementary, so I can say that angle L and angle M the sum of these two angles is 90 degrees. I can conclude that because of the original statement, law of detachment. Now, use the law of syllogism to draw a conclusion from the two given statements. If you exercise regularly, so that's my hypothesis, then you have a healthy body. That's my conclusion. Now we're going to start the next statement with the conclusion. If you have a healthy body, then you have more energy. Now, because of the law of syllogism, it says that I can tie these two together in a conditional statement and say, let me do that in red. If you exercise regularly, then you have more energy. Okay, number 28. This is a simple, you remember this, simple fact. Supplementary angles are two angles who have a sum measure, whose measures have a sum of 180 degrees. You remember that complementary angles have measures with a sum of 90 degrees. Alright, let me kind of draw this in for you on number 29. Picture didn't show up so nice. See if I could fill in everything we need here. We have 2y here, we have 142 here, and 2x minus 8 here. Find the values of x and y. Well, what we have here are intersecting lines, and we know that if lines are intersecting, then vertical angles are congruent. That means these two angles are congruent. Therefore, 2x minus 8 is equal to 142, and we solve for x. Add 8 to both sides, divide by 2, and x equals 75. So there's one of my answers. Now I also know that these two angles form a linear pair. And a linear pair means that their sum is equal to 180 degrees. So 2y plus 142 is equal to 180 degrees. Subtract 142 from both sides because I'm going to now solve for x. 2y equals 38. Divide both sides by 2, and we get 19. So y is equal to 19. Alright, let's look at the last question here. Again, this one can't read it very well, but we'll fill it in. So we have S here, T here, U here. Should be T. And we have 8x, and we have 4x plus 24. It says that T is the midpoint, which means that this segment is congruent to this segment, since the midpoint splits it in half. We're going to find the value of x, st, tu, and su. So knowing that these two segments are congruent, we can say that 8x is equal to 4x plus 24. Subtract 4x from both sides, because we're going to solve for x. And we find when I divide by 4, x is equal to 6. That's one of my answers. Now what I do is I replace 6 for segment ST, which is right here. So 8 times 6 equals 48, which is the measure of ST. Well, do I really have to plug anything into this segment right here? It should be equal to this segment, right? But we'll go ahead and check it since we know that x is 6. 4 times 6 plus 24, and that ends up equaling 48, because 24 plus 24 is 48. Now SU, how do we find the value of the whole thing? Well, isn't this just ST plus TU? 48 times 2, or 48 plus 48, is 96. So SU, the whole thing, is 96. Okay, those are all the notes for this chapter. Hopefully they help you for the test tomorrow, and good luck.